Hello my dear students, welcome back, and here we have one more problem from straight line motion, and this one is related to free fall. Okay, free fall. So we have solved certain problems related to free fall, and this is one more. And in the case of free fall, always initial velocity that is equal to 0 and acceleration due to gravity. You need to consider acceleration equal to acceleration due to gravity. Correct? It is 9.8 meter per second square. Okay, it is always negative. Acceleration due to gravity is always negative. Anyhow, in this, the question is, a body is released from great height, falls freely towards earth. Another body is released from same height exactly 1 second later. That means the time difference between first body and second body is 1 second. So second body is released 1 second later. That means first body has 1 second extra time. Correct? No? So second body is released 1 second later. That means first body is released 1 second before the release of second body. So if you consider second body has some time of fall 2 seconds, then what is the time of fall of first body? That will be 3 seconds, because that is released 1 second before. Okay, anyhow, now what is the question here? The separation between two bodies 2 seconds after the release of second body is. The separation between first body and second body after 2 seconds after the release of second body. Okay, let us try to draw one diagram for this so that we can easily understand the concept. So here you need to consider two bodies. Okay, so let's consider two bodies. This is the first body. Okay, first, and here you have second body. Okay, and both falls under gravity. So let's consider first body falls like this, and second body, which is released 1 second later, it falls like this. Okay, now both are released. So initial velocity is 0 and acceleration is acceleration due to gravity. Okay, now after 2 seconds after the release of second body, 2 seconds after the release of second body, that means let's consider this body falls for 2 seconds. Okay, falls for 2 seconds. So after 2 seconds that body reaches somewhere here. Let this position be some B and let this initial point is A. So after 2 seconds this second body reaches a point B. Then during that time, what about first body? Already this first body is released 1 second before that of second body. So before releasing this second body, this first body started its motion in downward direction. That means this first body has to travel some more distance compared to distance traveled by second body. Okay, so how much time you have for second body? As I said before, if this has 2 seconds, this must have 3 seconds. Why? This is released 1 minute. First body is released 1 second, not 1 minute, 1 second before the release of second body. That means you need to get the separation after 2 seconds after the release of second body. Okay, that means you need to consider the distance traveled by this first body in 3 seconds. Distance traveled by this first body in 3 seconds. That means after the release of second body it travels 2 seconds. Also you need to get you need to consider the distance traveled before releasing of the second body. That means you need to consider total 3 seconds, this total distance traveled in 3 seconds. Okay, anyhow, as I said, this first body has to travel some more distance compared to second body. Okay, so let's consider this is the distance traveled. Okay, can consider A dash B dash. Okay, A dash B dash, distance traveled by first body in 3 seconds. Okay, out of this 3 second, 1 second is before the release of this second body and remaining 2 seconds are after the release of second body. Okay, so now the question is, what is the separation? So what is the separation? That means this particular separation you need to consider. Separation between these two bodies after the release of second body. That means this distance, if you consider this as h, what is the value of h? That is what you need to calculate. So let this height be h2, okay, and this height be h1. Then what about h? Now you can write h is nothing but h equal to h1 minus h2, no? So that is what we need to calculate, separation between first body and second body 2 seconds after the release of second body. So just you need to calculate h1 minus h2. So we can make use of our general expression, that is x equal to v naught t plus half a t square. So anyhow here v naught t equal to 0, so x equal to half a t square you need to consider. So if you apply this for first body, just apply this for first body. So for first body if you apply, what do you get? Let it be h1 for first body. V naught t 0, half into a is nothing but acceleration due to gravity, that is g you can consider, into t square. For this, what is time for first body? If you name this as t1, t1 is nothing but 3 seconds, so 3 t square, that is nothing but half g into 9, 3 square is 9. So let it be equation number 1. Similarly for second body, if you consider, this is for first body, okay, for first body. Similarly for second body, you can apply same concept. So v naught t is 0, half into g into t square, so t is nothing but 2 seconds, correct, no? So 2 square, so what do you get? Half g, 2 square is 4, so let it be equation number 2. So finally what you need to calculate? h value is the h equal to h1 minus h2. Just make use of equation 1 and equation 2, simple calculation. So h, it is equal to half g into 9 minus half g into how much? That is 4. Okay, half g is common, so half g, 9 minus 4, 9 minus 4 is 5. So just simplify this. Okay, just simplify this. What do you get? H equal to half g value you can consider 9.8 into 9 minus 4, that is 5. Half of 9.8 means 4.9 into 5, that is nearly 5 into 5, 25, nearly 25. So or exactly if you want to get, you can, it is nothing but 24.5 displacement or distance, that is meter. Okay, so our answer is 24.5. just compare with options given. So if you look at the options, I think it is first option, correct? It is the first option, 24.5. Okay, yes.